Hey guys, welcome back to AlgoYogi. We are now doing stack series and our next problem is valid parenthesis. This is maybe one of the really common and most popular problems of stack or array or whatever you guys want to call it, but it's definitely stack that's usually asked, and it's really old problem. You can see it from the likes here. You can't see it actually, it's behind me, whatever. So given a string S containing just the characters, these are the different types of brackets, basically these characters, determine if the input string is valid. Now an input string is valid if open brackets must be closed by the same type of brackets. Open bracket must be closed in the correct order, and every closed bracket has a corresponding open bracket of same type. So I think you already know what a valid bracket string is. Just to go over it again, if the input is basically this parenthesis opened with this particular character and then closed by the same but the opposite closing character, that means that's a valid string and we will be returning true over here. And then we have our second example, that is opening bracket, closing the same bracket, opening square bracket, closing square bracket, and then curly braces, closing curly braces. Now this is a perfectly valid string because all these characters that appeared, all these brackets that appeared, they opened in the right order, they closed in the right order, and all of them matched perfectly with their own kind of character. Now here's the problem. This one is the problem, and this is the problem because it's opening with this parenthesis, but it's closing with this square bracket, which is not acceptable. So now we know what we are asked, and given these different inputs, how do we determine if it is a valid parenthesis? So it's a stack series, and we're definitely going to make use of stack to determine if our given this string is a valid parenthesis, order or combination or whatsoever you want to call it. So what we'll do is, we are given this string, we will iterate over our string from basically left to right, and then check if it's an open bracket. If it is an open bracket, then what we want to do is we will just want to keep appending to our stack. So let's say we'll make this little stack for this problem. So we'll make this stack, and then what I want to do is, if I see if any of my characters, so basically C is equals to either this or it's this or it's this, then in that case just append it to my stack. So if I'm seeing this particular braces, that means I just want to append it, so I'll append it to my stack, right? But if I'm seeing a closing one, else, elif, or you can say if I see this one, I'll take in the else case, but if I see a closing one, either this or this or this, that means I will need to check that there needs to be a value in my stack. So in this case, if I'm seeing this particular gentleman, so I need to pop out a value, and there has to be a value because that's when it will become a valid string. If this didn't exist, that means that is one case where we are going to return false, because we just saw this particular string, but this did not, it's basically corresponding opening bracket did not exist. That means we need this is going to be an invalid parenthesis combination. But now if I'm seeing this, then I need to check that my stack is valid. Stack has some character, and at the same time whatever I pop out from the stack, basically this needs to match basically the corresponding parenthesis bracket for these characters, which are for this it's going to be this one opening, for this one it's going to be a curly opening braces, and this one it's going to be an opening square bracket. So this is what I'm actually checking. There are two things that I'm checking when I am finding any of these strings. I will check if my stack is non-empty, and the last character that I want to see is a corresponding bracket that should match with the current closing bracket that I'm seeing, so that when I'm popping that out, now that closing bracket needs to match. I must have seen an opening bracket of the same kind, right? I think that makes perfect sense. So there are two things that I need to check. So I'll just get over this thing. I'll remove this and just write our algorithm. What we will be writing, we will basically go over our characters. So I'm going to write the pseudocode here, and now we have already understood what we will be doing, and then we will run over one problem. So I'll basically go over, I'll have a stack that is going to be empty right now. Then for character for C in my S, if basically, and also how about we make basically a little dictionary so that we are able to get the corresponding parenthesis. Basically, let's call it paldic. That sounds really bad, but let's go with it. And here we will have this you guys can't see it, so I'm gonna just make it over here. So paldic, parenthesis, not paldic, sorry, pardic. Okay, you know what, I'm just gonna call it dick. Okay, so this is going to have so first thing first, if I see this, then its corresponding value is going to be the opening bracket braces for this one, this parenthesis. Then if I see a curly braces, then its corresponding going to be the opening braces, and the last one, square closing bracket, is going to have an opening square closing bracket. They look a little ugly, but they'll do the job. So if my character in this particular dick, or closed dick I could say, so close dick, so I can check it over here, closed dick, if this is the case, then I want to check two things. First is if my stack, if not stack, or the last element in stack -1 is not equals to the combination of C in my closed dick. So close dick, and let's get out the value of C right now. If this was seen in my closed dick, if these are the values, if I am seeing close parenthesis, close curly parenthesis, curly braces, bracket, whatsoever, whatever you guys want to call it, but you know what I'm talking about, like these close brackets of each kind. If I'm seeing that, then I want to check that stack does have something. Otherwise there is nothing, and I'm seeing a closing bracket, that becomes invalid. I don't want to start any this valid parenthesis with a closing bracket, and it's not going to have an opening bracket in the beginning. That makes it invalid. So now what I'll do is, and if this is not the case, then I want to basically return false. Okay, I want to return false, else I will just pop the value from stack. So stack dot pop. Okay, stack dot pop. That's one thing, right? That's one thing. Now else case for this particular, if it was checking if they are enclosing, that means whatever character that I'm seeing is basically an opening bracket, so I'll just append it to my stack. So stack dot append C. Okay, now we come out of this loop, and then finally I want to return stack length of stack is basically equals to 0, because at the end what must have happened is every close bracket that I saw, I must have seen an opening bracket. So every opening bracket that I saw, I have appended it to my stack. So this will be a great example that I'm going to run. And so let's have a, oh my god, okay, so you can't see the code that I've written over here. Yeah, I didn't realize that, but now you can. Okay, so now you can. So what I'll do is basically I'll have I'll make it small, a little small, and yeah, this is all good. Okay, so let's run our code on this particular second example. So I'll make a stack, empty stack, and then what I'll do is make things a little smaller from this code and push them on the top. Now you can see the code really nice. Awesome. So I'll make the stack, second example I'm running, and I'm gonna just get rid of this third example for now. Second example, create this stack, empty stack. This step is done. Then I go through this opening bracket, so this case will match, else case will match. I'll push this in, second time this character, closing braces, it's in my stack, and I see stack is not empty, so I'll basically pull this out and try to check if this is not equals to this particular combination, but this is. So basically I do not return false. I come to here and I pop this particular opening braces from here. Okay, I pop this out, and the same thing gonna go for this one, opening a square bracket, and then I see the close one. I go into this particular case because I see that close bracket in close stick, which is the dictionary that creates this combination, 3 values. And then I see that whatever I pull out, basically I want to pop this thing out. I peek that this is the value, and this value matches with this particular combination, because if I use this as a key, I take out this particular value out and they match. Okay, I know it looks a little ugly right now, but you know what's going on. Now again I pop out from my stack. I pop this value out, so this value out, and then we're gonna do the same exact thing for this value, and then finally our stack is empty, so that means we return true. And for the last case, for the last example that I just deleted from here, that was example 3, and I think if I remember it correctly, s was this particular value, right? So in that case, you'll see opening bracket, you'll append it to your stack, but then you see this particular closing bracket, so you'll take out this combination and try to check if this value that you just took out from here is equals to basically, for closing bracket, yes, you're trying to check if this is equal, oh my god, if this is equals to this particular value. So this is definitely false, and we will return false from here. Okay, makes perfect sense. So what do we do? Let's implement our code. This is going to be a big of n time complexity solution, and space will also be same. And we're worst case, all values are just open, keep appending to your stack. So that would be it. But in best scenario, I think we might just see, you know, in an order, or n by 2 would be the max that we store these parentheses, because you keep seeing one type open, and then close, or any type, just all the brackets open simultaneously, like just at once, and then all of them close. There is no combination of open, close, open, close, open, close, but that too matching the order. So stack, and then we're gonna create like a parenthesis dictionary. I'll call it close close parenthesis dictionary, and then I'll have this one. This is the most used one. This needs to be having a value that opens like that. Then we see a close one like curly braces, its value is going to be open curly braces. Then third one is going to be bracket, close bracket, and then its value is going to be an open bracket. This is awesome. Yeah, this is a little cute dictionary that we have right now. So we're gonna start with C in S if C in my this little close parenthesis dictionary, if this is over here in this one. So I want to check if not stack, if let's say if not stack, and that's not how you write it. So if not stack or stack, by the way, this makes a short circuit. If not stack, if there is no stack value, then I will not be able to reach this statement where I'm checking its last value. The last value is not equals to this opening value of this particular character. So I must have seen something closing. It could be this closing, or this value closing, and at the same time, whatever I'm seeing, I must see its combination, its corresponding closing bracket as on the top of my stack, right? This is my top of my stack. What I want to see from the bracket, whatever the current parenthesis I'm seeing, it's opening bracket, because this is the close one, right? If this is not the case, then I want to return false. Otherwise I will return I'm not returning. Otherwise I will what do I do? I will pop from my stack. So I will pop stack.pop, because I found the right matching opening and closing brackets. Pop. That's a valid parenthesis that I just found. Get rid of that. You don't come out, right? Because you have other brackets to check still. That will fall in else case. Now if I am seeing another open bracket, so I will just stack.append and appending the C. Okay. Now in the end, either we must have come out, we ran through all the examples on our pseudocode. So either I have seen all the parentheses in the perfectly match in the right order, or you keep appending them but they do not match, so you never pop out, or you popped out some and some were not in the right order, so you didn't pop out all of them. So here you just want to return length of the stack, which is also an array, is equals to 0. If this is equals to 0, this is such a cute code. It looks so beautiful, isn't it? Yeah. So either the stack is empty and all the parentheses are valid, or they're not. So you will, I guess, you will return false. All right, then I am going to zoom out and run it on the examples. And I really hope it doesn't have any error. It doesn't. Let's submit our code. Yep, awesome. So let's write the time complexity. Time complexity is going to be big of n. n is the number of parentheses in our S, and space complexity is going to be big of n as well. Worst case, you see all the open brackets and there is no closed bracket, so you keep putting them onto this stack, and the length of the stack is same as your S. Alright, so we're gonna go back to AlgoYogi and mark this problem as solved, and see you guys later. Until then, bye bye.